Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this first video lecture of week 12 for the course Applied Linear Algebra, today we are going to learn about vector form of equation of line. Now, equation of lines in 3D space in 3 dimension. Consider the line L through the point P x0, y0, z0 that is parallel to the vector V, and the component of vector V are A, B and C. So you see over here, this is 3-dimension plane and this is vector V and this is the required line. So equation of line which is parallel to this vector V, and you see over here P naught is the initial point for this line, and Q lies another Q point is another point which lies on the line Q, and this is the another vector R whose component are x, y and z. So dear students, note that in this figure equation of line is parallel to a vector V, and this is the initial vector R naught whose component x naught, y naught and z naught, and this is vector R and whose component are x, y and z. This is 3-dimension plane x, y and z. So the equation of line in this vector form in 3-dimension plane are PQ is a vector. PQ actually is the line, but now this is in the vector form. The line L consists of all points Q, x, y and z, for which the vector PQ is parallel to the vector V. So this PQ vector vector is parallel to this vector V, and dear students, note that each geometrical figure is a set of points. So P naught is the initial point, and all other points Q is the point which lies on the line L. So there are so many points which lies on the line L, because line is a set of points. Now this PQ line will be x minus x naught. PQ mean Q minus P, subtract Q minus P, subtract P point from the Q point, we obtain a vector x minus x naught will be the x component, y minus y naught will be the y component, and z minus z naught will be the z component. So this is PQ vector. Now since PQ vector is parallel to the vector V, and we know that two vectors will be parallel if they are scalar multiple. So PQ will be equal to TV, where T is a non-zero scalar. So two vectors will be parallel if they are scalar multiple. Now multiplied this T to the vector V, we obtain, and you see over here x minus x naught, y minus y naught and z minus z naught actually PQ, and PQ is equal to TV. So multiplied T to the vector V component wise TV, TB and TC. Now rewriting this equation gives in the form x, y, z minus x naught, y naught, z naught. PQ actually Q minus P. So this is the Q and this is P. Now x minus x naught, y minus y naught and z minus naught, and you see over here x minus x naught actually represent x minus x naught. So this is P and this is vector Q. This is actually Q and this is actually P. And now this is the right hand side taking common T, and this is a vector V. Now solving for the vector x, y, z, solving for this vector x, y, z, which give x, y, z is equal to shift this vector to the right hand side, we obtain x naught, y naught, z naught plus TV. So this is the initial point, actually this is the initial point, and now setting R is equal to x, y, z. Suppose this is R, and you see over here in the slide this is R. X, y, z is the R vector. Now put R, replace this x, y, z vector by R, and this by R naught, and this is the vector V. You see over here we get the following vector equation of line. You see over here the vector equation of line in 3D space is given by the equation r is equal to r naught plus tv, where r naught is equal to x naught, y naught, z naught is a vector whose components are made of the points x naught, y naught and z naught on the line L, and v, a, b, c are components of vector that is parallel to the line L. So dear students, note that we have to find equation of line in vector form. So this is the equation of line in vector form, r is equal to r naught plus tv. So for the equation of line in vector form, we need the initial point r naught and a parallel vector v to the required line. So we can easily find the equation of line by using this formula, r is equal to r naught plus tv. Now if we take the vector equation r is equal to r naught plus tv, x, y, z, this is the r vector, is equal to, this is the r naught vector, x, y, x naught, y naught, z naught plus tv, this is the vector v, and rewrite the right hand side of this equation as one vector. You see over here there are two vectors, this is r naught and this is vector v. So rewrite this in one vector, adding the components. X component you see over here x naught plus at, y naught plus bt and z naught plus tc. So the right hand side in one vector form. Now this equality mean we can compare the components. X is equal to x naught plus tv, y is equal to y naught plus tb and z is equal to z naught plus tc. So equating the components of this vector give the parametric equation of the line. So you see over here the parametric equation of line L in 3D space are given by x is equal to x naught plus ta, y is equal to y naught plus tb and z is equal to z naught plus tc, where x naught, y naught, z naught is a point passing through the line and v is equal to a, b, c as a vector that the line is parallel to. The vector v is called the direction vector for the line L, and its components a, b and c are called the direction numbers. Now assuming a does not equal to 0, b does not equal to 0 and c does not equal to 0, if we take each parametric equation and solve for the variable t, we obtain t is equal to x minus x naught divided by a, t is equal to y minus y naught divided by b and t is equal to z minus z naught divided by c. Equating each of these equations gives the symmetric equation of line, and you see over here the symmetric equation of line in 3D space is given by x minus x naught divided by a is equal to y minus y naught divided by b is equal to z minus z naught divided by c. So dear students, you see over here how to find the symmetric equation of line. You see over here in the next slide. So solve the parametric equation of x for t, y for t and z for t. So for t, x minus x naught divided by a is equal to t, y minus y naught divided by b is equal to t and z minus x naught divided by c is equal to t. So both equation equal to t, and now you see over here t is equal to this, t is equal to this and t is equal to this. All of these three equations equal to t. So by comparison we obtain the symmetric equation of line is equal to x minus x naught divided by a is equal to y minus y naught divided by b is equal to z minus naught divided by c, where x naught, y naught, z naught is a point passing through the line and v is equal to a, b, c is a vector that the line is parallel to. The vector v is called the direction vector for the line L, and its components a, b and c are called the direction numbers, and I have already told you about these points. Note that to write the equation of line in 3D space, we need a point on the line in a parallel vector to the line. So when we have a point on the line in a parallel vector to the line, we can find the equation of line in 3D space, and we can write equation of line in symmetric form, equation of line in parametric form, and equation of right in vector form. So you see over here in these slides, we have actually three formula. The first formula is a equation of line in vector form. So this is the equation of line in vector form. Three formula should be noted. Equation of line in vector form. Equation of line in vector form, one initial point is required and other the parallel vector is required. And the second form, equation of line in parametric form. You see over here, this is equation of line in parametric form. Equation of line and parametric form. And how to derive the equation of line in parametric form? You see over here, from this formula, this is actually equation of line in vector form. So first of all, the right hand side vector, write the right hand side vector in a single vector, and then equating the component, you will get the equation of line in the parametric equation of line. And now solve these three equations for t, you will obtain equation of line in symmetric form. So the equation of line in symmetric form, you see over here, this is equation of line in symmetric form. The symmetric form of equation of line, x minus x not divided by a, y minus y not divided by b, and z minus z not divided by c. So this is the symmetric form of equation of line. And for each case, equation of line in vector form, you see over here, equation of line in vector form, equation of line in parametric form, and equation of line in symmetric form. We need one initial point and one parallel vectors. So when we have one initial point, you see over here, when we have one initial point and one parallel vector, we can easily find all these three types of equation of line. So dear students, actually in this video lecture, you see over here three types of equation of line, and all these type of equation of line are called vector form of equation of line. And inshallah, in the next video lecture, we will discuss some problems related to equation of line in vector form. By this formula we can find equation of line, and by this formula we can also find equation of line, and by the symmetric form we can also find the equation of line. So inshallah, in the next video lecture we will discuss all these three types by some numerical problems. And now this is the end of this segment. Thank you. Allah Hafiz.